In 1.7, we are going to move from equations to inequalities. When we say inequalities, we do not mean x is not equal to 2. That's not an inequality. So for it to be an inequality, we need to specify if it is a less than or equal, a greater than or equal. So you need to get familiar with those signs. And we have properties of inequalities. First of all, if a is less than b, then adding c to both sides of the equation is not going to change the inequality. If a is less than b and c is a positive number, so in this section we're going to start learning about learning to see in front of our eyes that when we say c is greater than 0, we mean positive, c less than 0, we mean negative, because we're going to use the signs in this section, section. So let's go back to number 2. If a is less than b and c is a positive number, then if we multiply ac to both sides of the equation, that also is not going to change the inequality sign. But if we have an inequality and c is a number less than 0, meaning negative, then if we multiply both sides of the inequality by that negative number, then we have to flip the sign. And these properties are the same whether we are talking about less than, greater than, less than or equal, greater than or equal. It's the same properties for all of them. And we're going to start with linear inequalities. And a linear inequality, just obviously a linear, meaning ax plus b. Again, either greater than or equal, less than or equal to 0. And before we start doing examples, a quick review of how to graph inequality and how to write the interval notation. So this here is important. We are not going to use set notation in this course. Again, not. When we solve, we end up with something like x greater than a, x is greater than a and less than b. We're going to get all that, but we are not going to use the set notation. But the set notation is read as follows. This is the set of all x's such that x is greater than a. Again, we're not going to use it. But what does it mean, greater than a? In a line, a number line graph, you pick a place. I'm not gonna start writing 1, 2, 3, 4. You just find a place, call it a, and if I say a is x is greater than a, that means it's gonna go to the right. So we have to darken it. And if we don't have a less than or equal, it's not equal to a, so we're gonna use a parentheses. Some books uses open circle and dark circle. We are not going to use it in this as an interval, as in graphing inequality. Okay, so 3 ways inequality. We read it from the middle. We say x is greater than a and less than b. So it is obviously between a and b, so the interval notation is a to b, and the graph is both parentheses because there's no equal sign. I forgot to talk about the interval notation. Again, the number line goes left, negative infinity, to the right, positive infinity. So the order does matter. So when a is greater than a, so it's a to infinity. But here, x is less than b, so we go to the b, we have the parentheses facing the left hand side, and we have all the values that are less than. So our inequality, which is x less than b, can be written in interval notation as from negative infinity open. We can never close the infinity because that's not a number, it's a symbol, so it cannot be included. Negative infinity to b. So I'm going to just mention one of these and I'll let you look at them and get familiar with them. I mean, you should be familiar, but if you forgot, this is a good way to remember. Or maybe you did not study it that way. If x is greater than or equal to a, then there is an equality. So a, it could be a, so we're going to use a bracket. Again, this bracket and parentheses is going to be very important. It affects a lot of your points and grades, so be careful. If we are including, then it's bracket a to infinity. Look at this one, it is x is greater than b, there's no equal, and less than or equal to b, so it's open on the a but closed on b. Open on the a, closed on the b, and vice versa. And the only closed interval is when we are including both ends, so from a to b. And when we say all real numbers, we mean negative infinity to infinity, and it's the whole number line. Okay, so let us start example 1. We are in all these examples gonna ask you to solve, graph, and give the interval notation. So all three, every single problem. So I did the first one, let's do the second one. It's just like an equation. The only time we're gonna worry about anything is when we multiply or divide by a negative number. So a linear equation, so let us subtract 2x from both sides. So we're gonna have 3 minus 2x greater than or equal to 8. Again, I just subtracted 2x. Let us, I don't know why today I don't want to write the 2 nicely. Okay, negative 2x is greater than or equal, subtract 3, so that's a 5. Now to solve for x, we need to divide by a negative 2. That's a negative number. So what are we going to do? Switch the sign to less than or equal to negative 5/2. That is one part, which is the solving. Now the graphing. Find you any place and call it negative 5/2. And x is less than or equal, so it is an equal sign, so it's a bracket, and you have to darken it. Okay, whether you use colors, whether you use whatever you want, just darken it for me. And then the interval notation is from negative infinity to negative 5/2, closed. So every problem we're going to ask you to do all these three things. Now, 3 ways inequality. Again, I worked one for you, and let's do one together. So the idea behind solving a 3-way inequality is to isolate x in the middle, just like this. This is the final answer. We need x by itself. So we can see here that there's a 1, first of all, added. So let's subtract 1 from all sides. So we're going to have 0 less than negative 1/2 x. Less than or equal, again, we're subtracting 1, and whatever you do to all 3 parts. Now, I need x only, so of course you can do it in multiple steps, but if you're smart, you're gonna do it in one step, and that one step is to multiply by the reciprocal, which is negative 2. So again, we're gonna multiply this whole inequality by negative 2. If it's negative, then again what's going to happen is we're going to switch the inequalities. So first of all, 0 times anything is 0. Instead of less than is greater than. When I multiply negative 2 times negative 1/2, I get x. When I multiply by a negative number, it's going to switch the sign, and this is going to be negative 6. So we think we're done, but we are not, because this is never going to be acceptable 3-way inequality. X should always be greater than something to the left, less than something to the right. So we need to rewrite this as, since this x is greater than or equal to negative 6, so it's greater to something to its left and less than to something to its right. So that's the answer. Again, that's how we read it. Let's graph it. So we have a negative 6 and a 0 somewhere. It's greater than or equal to negative 6, so to the right and including negative 6, but less than 0, not including 0, so it's this part. And the interval notation is very similar. Mhm.